Okay, we're going to look at a simple circuit today. We have a 1K resistor. We have a 0.01 microfarad capacitor. That's 0.01. And input output. So what is it? It is a low pass filter. Because if you have high frequencies, the high frequencies will go through the capacitor and down to ground, and it'll attenuate them. So when the amount of AC goes through the capacitor, there will be some frequency where this will look like a 1K resistor, and you'll only get half of the it will be a resistor divider, you only get half of it out. So it is a frequency dependent resistor. You can think of it that way. Anyway, it's a low pass filter. So we're going to have input and we're going to have output, and we're going to measure this thing. We're going to measure what's called a Bode plot. No, it's not Bode. It's actually pronounced Bode. Look it up. Bode plot. And Mr. Bode came up with this. So what we're going to do is we're going to hook up a generator. Okay. We'll have a generator here, and we'll put that through. And then we'll measure the input and the output. Okay. So we're going to come in here, and we're going to come in here. We're going to use two oscilloscope probes. We'll have channel 1 and channel 2, okay? So channel 1 will watch the input, channel 2 will watch the output. Then we can do mathematics on it. So channel 2 divided by channel 1 is the gain, right? And in addition to looking at the gain, we can look at the difference between channel 1 and channel 2 in phase. So there'll be a phase delay as this thing goes through. The phase will change as it goes through the system. And the graph of frequency and, or the graph of gain versus frequency plotted on top of phase versus frequency is the Bode plot, okay? So I have something hooked there up here. We've got the two probes. We've got the generator, and we're going to use this nice machine over here. All right, so this machine has the Bode plot built into it. It's one of the applications. So if you click on menu, you can go to applications, or this button down here is the applications button, and there's various things, all right? And one of the things is the Bode plot, and I have it defaults to certain windows, but this is the way that I like to see it, so I've changed the window so that we get the Bode plot here, and then we see the input and the output. Yellow is input, green is output, and then over here is a list of points. So we set it up. We're going to start at 1 kilohertz. We're going to stop at 1 megahertz. And then we're going to have so many points per decade, and then we'll have 10 points per decade. So what is a decade? Well, that's from 1 kilohertz to 10 kilohertz. That's a decade. 10 kilohertz to 100 kilohertz, that's a decade. And 100 kilohertz to 1 megahertz, that's a decade. So we'll have 10 points between here and here, and then 10 points, and then 10 points. We'll have 30 points altogether, okay? And then we can hit the run button. That's a previous measurement. So up here, we can kind of watch what's going on. You start out that the input and the output are both identical, that you have a gain of 1. And then as you start getting a resistive division, you'll start losing dBs. So we're down now minus 7 dB here. And we'll continue to lose gain because we will be killing high frequencies. Remember, this is a low pass filter or a high cut filter. And so the green plot is the gain, and the red plot is the phase. The phase you read over here in degrees, and the gain you read over here in decibels, all right? And they're also here in this chart. Frequency, gain, and phase. There's the phase. Oh, let's get rid of this thing here. How do I get rid of that? I just want to get rid of that. There we go. Yeah, so frequency, gain, and phase is in this table here. And we have the plot over here. So very, very nice setup. I do like it. It's pretty speedy. There's some markers. You can slide markers around to measure things like a 3 dB, the 3 dB point, or the 30 dB of attenuation or something. You could set these. They're right here, M1 and M2. So M2, yeah, that's about 30 dB, and then we'll set M3 to about 3 dB, and 3 dB is up about there. So we have a 3 dB point at 3 kilohertz, and a 30 dB, or -6. Wait a minute. M2 should be 30 minus 60. Oh, this is -6. I'm sorry. I wanted -30. I was looking at the wrong scale here. There we go. -30. -30 is at 630 kilohertz. All right. So yeah, there's our 3 dB down and our 30 dB down. So this is a single pole filter, simple filter. Yeah, it's a pretty nice machine.